So Marcin Kubacki is with us. And Marcin is my dear friend from Storware, and we'll talk about the data protection, the backup and recovery capabilities for the OpenShift based on the Storware Vprotect. So also we'll go with a few slides, explanation why the backup is important for the modern workloads such as containers, and we'll do some live demos. So Marcin will present how to do it through the operator, so how to make the installation and configuration easier, and we'll show you exactly the product itself. Like always, if you have any questions, just feel free to ask in the meantime, and in the end we'll do the official QA. So thank you for being with us here, and Marcin, like I used to say to the other speakers, the stage is yours.
Okay, so if stage is mine, then well, containers. Okay, so today we look forward to see more and more of such environments being deployed everywhere, and disaster recovery also happens to be quite an important factor if you think about containers as well. Obviously, the overall deployment process has changed, so the persistence layer has been moved towards some stateful sets or stateful containers, let's say, but still this data needs to be protected. And with Vprotect, we have quite a wide range of sources already that we support. OpenShift and Kubernetes is one of them. Now, this is the central point of this presentation, but notice that the overall background is where Vprotect comes from is actually from the, let's say, open source hypervisors world. Not only virtual machines, but also containers, instances in the cloud. We are also going to discuss other sources which might be quite useful if you think about OpenShift itself. So main features, whenever we talk about Vprotect, think agentless. So whatever the source is, our goal was to have basically VM level, container level, application level, instance level, whatever level you might think of, data protection without the need to install agent everywhere. Now, snapshot management capabilities, if it's only supported, think about the storage, let's say, volumes that you might want to keep some set of snapshots to be able to roll back quickly, but also snapshots residing on the used by the virtual machines themselves. Application backup, that's a generic mechanism that's specifically designed for consolidating all of your native scripts, commands, whatever you have into a single console, and it allows you basically to move the data protection scripted way into the fully centralized solution and keep track of daily, let's say, backup status. Storage backup. Now, this is quite new, and this is going to expand a lot. In OpenShift environments, these persistent layers obviously is kept on, let's say, in some storage which can be, well, Ceph is actually gaining popularity, which, by the way, is supported by Vprotect right now. So a standalone storage provider called Ceph RBD, and you can scan for volumes and protect the same as you do for regular instances, either deployments or virtual machines. Now, whenever you have a disaster, then sometimes you just need to click this magic button, restore all of my virtual machines or deployments in this case, with recovery plans. So this is the way that you can create a policy that basically describes where these environments needs to be restored. Sometimes you just want to test if your backups are working with periodic scheduled recovery plans, so that you have periodically restored set of deployments. Everything can be automatically assigned based on these labels that you have in the OpenShift to the policies, and these policies later push basically allow you to specify to which backup destination you would like to store these backups to. So it means that Vprotect is the component that allows you to integrate smoothly with your existing either storage, it can be object, file system, or enterprise grade backup system, and your OpenShift environment, which is very, very new and Vprotect would perfectly fit into the middle of that. Now, whatever I'm going to show you today is going to be accessible via RESTful API, so we can automate it easily with whatever you would like, including Ansible that we have discussed today. And we have some plugins dedicated for platforms like the OpenStack and others. So the missing puzzle is actually here in the middle. You can see that there is a wide range of sources in here. We are today focusing on the containers world, so mostly deployments in this case. But notice how wide range is available on the right side of this picture. It's not only file system. It can be there. It can be some object storage. It can be also enterprise grade backup provider. Now, with Vprotect, we have actually two main components. One is server, one is node. Node is responsible for data movement, so it is actually connecting to your OpenShift cluster and doing the dirty job, while server is central placed, easily accessible via RESTful API and web interface, so we can easily manage the overall platform. If you take a deep dive into the architecture, notice that whenever we approach OpenShift platform, we can think about different aspects of data protection. We can think of, let's say, deployment, similar like it is with the virtual machine, for instance. It has its metadata, it has also set of persistent volumes, and this is what we actually are focusing whenever we talk about this virtualization integration path that you can see on the left. Then you have custom apps running inside your containers. You just don't want to backup persistent volume level in the data from the persistent volume level. You prefer, in this case, to execute some specific command on the database, maybe, that allows you to grab data in a native way, in a consistent way, like it is, let's say, with MariaDB, for instance. So the application backup is a generic way to execute such script. You can backup your etcd database maybe to the other backup providers or the object storage or other target. And finally, storage providers, especially useful with Ceph, because Ceph is becoming more and more popular with the deployments, with the OpenShift deployments, and this allows you to focus just on the storage level. You scan for the RBD volumes, you create policies related just to these volumes, so the same backup policies or snapshot management policies. Both of them are supported for Ceph currently. So node processes data and pushes it to your backup destinations. Server, on the other hand, hosts the APIs and has the metadata database, which allows you to, which can be easily backed up because it's also a small database, so you are not going to use any of your backup metadata. Two strategies for the data protection for the deployments themselves. So we are in this picture, actually we are focusing on the deployments. First is for file-based persistent volumes. In this case, we are able to access data via helper pod. It's going to transfer data directly from within the persistent volumes attached to this helper pod. So it's similar to the sidecar pod approach, but it is a global sidecar pod, so it's not going to be deployed with every deployment that you have. And then data is fetched to the node and pushed outside the backup destination. The other, more focused around the Ceph, notice that Ceph RBD allows us for snapshotting in this case. So we are talking directly to the Ceph to create both full and incremental backups in this case. On the Ceph RBD volume, and data transfers occurs directly from the Ceph monitors, which is going to perform far better and is more suitable for bigger deployments, especially when you are using Ceph RBD. There is an optional switch that you can enable if you'd like to have a consistent backups, to have the option to pause deployment if you need it. It may not be suitable without the maintenance window, but there is such option. and option to execute some pre-post export remote command executions inside some system. Okay, it's arbitrarily, it can be executed over SSH on the deployment if you enable SSH, but in general there is such option as well. Now, with the deployments in the OpenShift, we are used to use labels, and labels serve us here as a tag. So in general, tags are collected from from most of the platforms that we support. In terms of the OpenShift, it is basically mapped to the label, so it has key equals value, and it can be used to match appropriate deployments automatically and automatically assigned or removed from the policies. Backup consistency, by default, it's crash consistent. Remember about file system based deployments, persistent volumes, they don't support by default snapshotting on the file system. So if you would like to have typical crash consistent backup using snapshots, then Ceph RBD would be required, or you can optionally deploy pause deployment during the export phase. Now, recovery plans. You would like to be prepared for your disaster. So with recovery plans, you can define which VMs are going to be, well, VMs, deployments in this case, are going to be recovered into which platform. Especially secondary cluster if you lose your primary in this case. You can do it periodically or on demand. And you define set of rules. So remember that recovery plan can match actually multiple deployments or virtual machines actually with the same and actually you can invoke some more complex recovery procedure in this case, because you may want to restore a set of virtual machines, let's say in VMware or Ref, but at the same time restore several deployments in the OpenShift environment. And all of that can be achieved with multiple rules related to the specific platform inside the recovery plans. Now, application backup, as I mentioned, is quite generic feature. So you have basically two concepts. One is the execution configuration. It describes how you would like to perform backup. The end result is going to be a file, set of files, maybe the output of your command. It can be executed either remotely or on the node. And the application itself is then an instance. So you can define, let's say, a script or a set of commands with your execution config and reuse them multiple times with the application. So here you're going to basically specify the name, if it's going to be remotely or local, if it's going to be a remote or local command, the arguments of it. If you would like to export data, it may not be obvious, but in some cases, like the Airman, you may just want to initiate some external backup process. So you treat Vprotect as a scheduler. And finally, the parameters. So parameters inside the execution configuration, these are basically mapped to the environmental variables later used in your application definition. So you provide the values. This way you are able to have a smooth way to catalog all of your different execution configurations into one place and later reuse them with the multiple application instances, so that it's easy for you and other administrators to keep track to which specific script or command is used where. Now let's start maybe with some live demo, and let's play an operator installation. This is how we install the operator in our environment. Oh yeah, okay. So we start. It's still loading. Okay, so to install Vprotect, you can either use standalone installation using some external OVAs deployed outside, or you can install it directly using operator inside the OpenShift cluster. So here we show you how to install it with just a few clicks into the OpenShift itself. So first thing is to go basically to the operator hub. And inside the operator hub, you need to find Vprotect operator. This operator installs later, once it is going to be executed, an instance of the Vprotect inside this cluster. So with simple click in the marketplace, we are able to download operator, and it's already present inside our OpenShift cluster. Now we are going to copy the storage class. This is required later to to map properly the volumes, persistent volumes inside the installation script, during the operation of the install. And you notice that in the Vprotect operator, there are a set of entries related to the storage class and related to the appropriate images inside the repository. So we are going to replace all of the storage class name wherever it is required. It is in a few places. And the operator itself has some options related to the way you provision the storage for the node itself. So inside the node, you can have either staging space already installed as a persistent volume. It can be automatically initialized with the deduplication layer optionally, or it can serve basically as a complete proxy in this case. So you just may want to use a small staging space on the node and push data to some object storage if you need to. So in this case, you can see that we are going to have a simple persistent volume installed inside the container itself. Okay, let's scroll a bit. Okay, the movie seems to be running, but it's not changing, which is strange. Okay, so let me just scroll to this moment. So now the values of the images that you are using inside the deployment script, you just need to make it short. Let's cut them and save the YAML. So we have replaced the config. Inside this config, notice that there are also some information related to the database connectivity. We have just left the default passwords in here just to provide you the demo. So once you have modified the operator itself, then you use the option to deploy, to create Vprotect instance. And again, remember about the storage classes that you have provided. This is going to provision automatically persistent volumes of the size that you have specified. And whenever you provision the instance, notice how many artifacts are being scheduled. So persistent volumes, persistent volume claims, and several other artifacts. Several deployments divided into the database, server, and node. So this is going to be an all-in-one installation. For OpenShift environment, if you are using this operator, you are going to use a single node per cluster. But scalability that we have discussed earlier, it doesn't prevent you from running external nodes as well on the other platforms. So you can have the OpenShift running in here, protect OpenShift from using this operator, but connecting external nodes to your instance running in the OpenShift here to be able to cover multiple different heterogeneous virtual platforms that you have in your infrastructure. Once it is deployed, you just need also to create a route that it points basically to the Vprotect server, so you are able to reach the Vprotect server API and user interface. So we have created a route, and whenever we click it, it basically points us to the actual Vprotect instance. Okay, so now let's log into the actual instance that I have in here. So let me log into the Vprotect installation. Notice that we start obviously with the dashboard, and there are three main areas that we cover with Vprotect. So virtual environments, specifically we call it that because we mix virtual machines, containers, instances in the cloud within under a single umbrella. Then you have the applications and storage instances. So this reflects basically what I have in my environment as well. So we start with virtual environments, and inside the infrastructure tab, I'm going to have the Hypervisor Manager. It's a generic way, the generic term of the source for the virtual environments manager. And you just define the appropriate credentials to your OpenShift OpenShift platform, specifically username or token. Here is password, but it can also be it can also use the token to access your OpenShift cluster. So the inventory synchronization task is going to collect all of the information about the running deployments, persistent volumes, nodes as well, because whenever we have the OpenShift, notice that we have set of the worker nodes and some management nodes, which are detected here as the hypervisors, and you can specify to which of them needs to be covered by your license. But you can notice that I have several nodes in here running several deployments detected, and inside the instances view, this is where I can find later my deployments. So let me just invoke Mongo, which corresponds to the deployment that you can see in here. Here is my deployment inside my OpenShift platform, and I'm going to initiate the backup. It's going to be full backup, and inside the node I have the local file system, which has probably even enabled the duplication, which also can be easily enabled with a single click whenever you create backup destination. And it creates a task. So everything that node does, like previously I have executed inventory synchronization, it is a task to the node. You can scale up with multiple nodes or executing different set of tasks at the same time within the limits that you specify, a number of simultaneous exports, stored, and so on. So we can notice that export job basically means that data has been exported from the environment, and store means that data has been pushed to the backup provider and the backup is complete. Inside this details tab, you can notice that I have my tag, label, assigned to this environment, which I can later use to specify inside the automatic assignment policy rules to automatically include this virtual machine into my policy. Some activity charts, especially some statistics about the transfer rate, how fast it was, some restore statistics. We also have included several test restores in this case, and sometimes you just need to focus on a specific phase. Maybe I'm not interested in the queue duration. I would like to compare basically the amount of time spent in during specifically transfer. Complete backup and restore history in this case. Our desktop in this case shows persistent volumes, so it is going to detect both the file system based volumes and the Ceph RBD volume if it is used in there. Inside my backup SLAs, notice that I have two tabs, policies and schedules, and policies have the tab automatic assignment. So it's not only about the tag based automatic assignment, but also by the name. If you have a naming convention in your OpenShift cluster, then it is also a good way to create some include and exclude rules, maybe specific to this cluster, not only based on the names. Inside virtual environments, you obviously assign which deployments you would like to include inside this policy, and the rule specifies according to which schedules and to which backup destination you would like to store your backups. Snapshot management is not supported for the OpenShift deployments, but it is supported for the SEP volumes. So if you are using storage provider. Now, the application tab allows you to define this execution configuration and to define execution configuration like we have, let's say, for the MySQL Maria. And notice that these parameters here defined by the, let's say, one of the administrators later allow you to be propagated into the actual instance. So my Maria, let's say, and is going to be MariaDB. This one, let's say, requires some fake access to the to some non-existing host. And notice that here in the settings, I have pre-propagated environmental variables that I just need to fill up. So the name of the database, for instance. This allows me to easily copy and paste the same approach for multiple applications and later push it to the appropriate backup destination within. Look, that basically it corresponds to the same view that you have here. So this allows you basically to protect OpenShift etcd deployment applications residing into the deployments, and it extends the regular deployment-based data protection. And to extend it even more, if you have Ceph RBD and you just want to have snapshot management capability, or just focus basically on the volumes that they are provided by the Ceph RBD storage provider, you are using then storage provider section. So storage section allows you to define storage providers, and one of them is Ceph RBD. We also support Nutanix files. It's not really related here in the with the containers themselves, but file system may be also useful to protect some specific shares. So if you have persistent volumes residing on the common shares, you also are able to protect in an agentless such shares with the nodes running Vprotect to have central view of all different data flows that you have. Multiple backup destinations, its file system, its object storage, and it has the enterprise grade backup providers as well. So if you have existing IBM, Dell's, or Veritas solutions in your data center, that is the way that you could integrate them smoothly. And everything that can be smoothly divided with the access management that we have extended with their latest release is going to be full RBAC support with the next backup, next release as well. So that basically summarizes the demo for today. Pavel, the stage is yours.
Mine right now? Great. Marcin, like always, I ask everybody who participate today and do the presentation how I should play the Storware song.
Yeah, I think that it should go something like this. First, it's slow because everything works as you might expect. Then suddenly there is a disaster, so it should be hard, and you invoke the recovery procedure. Once it is done, you can play it slow again because you're chill after a successful restore.
Okay. So I will go in an easy mode. We have already we have a prepared clip. We've played with our band Bear Machine. We started the meetup with this song. It's in Backup We Trust. But right now you will have a chance to see not only the music itself, but also the full clip. So 4 minutes in Backup We Trust, and then we'll have a QA session with all of the experts in the one time. According to disaster, yes, your presentation was one of them.
One of them, disaster.
the disaster. But no worries, we'll try to recover it during
easily.
the QA. Thank you, Marcin. In Backup We Trust, we'll see in actually between 4 and 5 minutes.
Run!